Friends, today's topic is the part checking of a front load washing machines. So front load washing machine is this is the total program is controlled through a control. There is a controlling part and was a functional part. Okay. In controlling part, we have a display PCB. Somewhere we have a touch display and the controller part and main PCB and the driver PCB. Okay. In the functional part, we have a pressure sensor, door lock, inlet valve, heater, drain pump, and main motor. And different type motor we are using conventional AC motor, BLDC motor, and DG motor. Okay. Now we will check how this all these parts are connected, internally connected with the controller, and how we can check all the parts one by one. Okay, so that in field, whenever we face any problems or any error, that time we can easily check the part and accordingly we can identify the actual defect of the unit. Okay, let's first check the how this all these parts are internally connected, and then we will check how we can check all these part individually. Okay, let's check. So first, initially I show you how all these parts are internally connected. Okay, so if you power on, okay, so first there is a noise filter. First power goes to noise filter, and from noise filter to power goes to directly come to door lock and the heat main PCB in relay. Okay, and one point need to check this is the main power supply, and whenever this relay will on, the outgoing supply directly goes to the main heater. Okay, so in any cases if this relay is going to direct, okay, internally direct, okay, in that case whenever you power on the unit, directly heater will goes on. Okay, because this is the main power supply and this is the outgoing supply to heater, and this supply will go after whenever this relay will on. So that should be checked properly. Okay, and this is the door lock. This is the pressure sensor. Pressure sensor is already, I say, connected from display PCB. Okay, this is inlet valve. This is inlet valve also connected from main PCB. Heater already I said connected from main PCB. This is drain pump. Drain pump also connected from main PCB. This purple and purple wire. Okay, and after that, there is driver PCB. Driver PCB is connected from main PCB, and driver PCB is giving the output supply to main motor. Okay, and driver PCB and main PCB is internally connected to this communication 12-volt supply. Okay, so all the supply I will explain details in another video, but you I want to say you here the how all these parts are internally connected. Okay, now go to the next steps. Now we will check part by part how we have to check the all these parts. Okay, and how much supply came from at pressure sensor or drain pump or heater or inlet valve and display PCB. Okay, so after first power on, first we have to check is there any display on or not. Okay, if display on, that means we have a supply at display. If no display not on, in such cases we have to check the supply at display PCB. Okay, for that in this connector we have to check, as we earlier mentioned, display will work at DC 12 volt. Okay, black and red 12 volt came, and black and blue also 12 volt came. That means supply from main PCB to display PCB is okay. Now display PCB will provide supply 5 volt supply to pressure sensor. If there is any error like FA, okay, that is pressure sensor related. In such cases, we have to check the voltage DC supply at pressure sensor. So between black and red, we have a supply voltage 5 volt. The 5 volt supply is there, that means display PCB is providing supply to pressure sensor. After that, if error came, that we have to check the connectors. Most of the cases, this connector pins got damaged and sulfur. Okay, and some cases the gap between these pins may be more. In such cases, same error came. Okay, accordingly, we have to check there is any sulfur or moisture is there or not. After that, we have to check the voltage at inlet valve. Inlet valve will work at 220 supply. Okay. So here is a two separate inlet valve is there. Here is a neutral is common and two supply is there. Okay. So after program 1, first we have to check this. This is red is common, neutral, and we have to check the voltage between red and yellow and red and black. So must start. We have to check the voltage as AC. Two double on supply is there. After that is first valve will on. After that, next valve will on, and then cases we have to supply 220 supply at red and black. Okay, that means PCB is providing, main PCB providing supply to inlet valve. Okay, after that, if my valve is not working, in such cases we have to check the inlet valve resistance. Inlet valve, generally we are use two types of inlet valve. One is non-NZP, another one is NZP. Non-NZP valve resistance will be kilo ohms at between 4.5 to 4.8 or 4.9. And for NZP valve, we have a resistance between it at mega ohms, 10 to 15 or 10 to 17. Okay, it will vary. Now we have a near about 10 mega ohms. Okay, so non-NZP valve we have a resistance at kilo ohms, and for NZP valve we have the resistance at mega ohms. Okay. Otherwise, we can directly 220 provide the 220 supply here and can check whether this valve is working or not. At door lock, there's mentioned 1, 2, and 3. Generally, 1 is common, 2 is supply line, and 3 is neutral. Okay, so between 2 and 3, we should have 220 supply, and if we check the resistance, we have a resistance near about 200 at 2 and 3. Okay, so first we check there is supply is there or not. So in connector between blue and brown, that means 3 and 2, we have a 220 supply. So 220 supply is there. Okay, that means PCB is providing supply at door lock. And we don't have any supply between 3 and 1 in unlock condition. In lock condition, we should have the voltage 220 supply between 3 and 1. In that condition, PCB will work. As I told, between 3 and 2, we have a resistance near about 200. 205. Okay. 3 and 1, we don't have any resistance. Okay, because this is the common. After power supply provided, door lock is on. In that cases, this supply will return back from point number 1. So we don't have any resistance between 3 and 1. The resistance of the heater is between 30 to 35. And this is NTC sensor. Okay, connectors. Sometimes some corrosion sulfur is there. This is NTC sensor, and we have to check the resistance of sensor. It comes at kilo ohms. It is between 4 to 10 kilo ohms. But if the resistance is more than 1.5 mega ohms, that means the sensor is defect. So sensors we should check at kilo ohms. So drain pump we should check at resistance, and drain pump will work at 220 supply. The drain pump resistance will come between near about 200, 170 to 200. It's showing 174 ohms, that means drain pump is okay. If there is no resistance is showing, that means drain pump is defect. In the same way, we can directly provide 220 supply here and check drain pump is working or not. And the motor, if there is a DC, BLDC or DD motor, we have to check the resistance between U, V, W, or as per color wise, blue, red, and yellow. Okay, all the 3 pins resistance will be same. For BLDC motor, we have resistance near about 6 to 7 or 7.5. Okay, and all 3 pins, the resistance will be same. And same for DD motor. At DD motor, we have to check the resistance at stator. Okay, in stator, you have a 3 pins mentioned: yellow, blue, and red. Between red, blue, and yellow, we have, and all the 3 pins, the resistance will be same. Also remember, some points there should be some sulfur or maybe some corrosion is there, or due to that the motor will not work. In that cases we have to check that. And whenever you fit the motor, okay, or replace the motor, you should check the color wise: red, blue, and yellow should be same. No interchange should be there. Okay, otherwise may your motor will be damaged or may machine will not run. Okay, so very carefully we have to put this jack whenever we replace, or for any condition we open these connectors. Okay, that should be remembered. So at field, whenever we facing such problems, okay, in such condition you have to check one by one part accordingly. So same, if I first power on the, okay, and then set some program and on. So initially first door will lock, so noise is game, and you have to also check the LED should be on at driver PCB, at in main PCB. If LED is not on, that means some problems is there, and accordingly you have to check the voltage at main PCB. 220 supply is there, and in driver PCB 220 supply is there or not, that we have to check. And same I will discuss in another video, how to check all this, how to check the main PCB or driver PCB. So now I am trying to explain you it in field. Whenever you feel some issues regarding any problem, errors, or maybe machine not working, in such cases how would you check the parts? Okay, and as per guidelines you have to check the parts or spares in the field, so that after proper checking you can replace the part. Without proper checking, no need to replace the parts. Okay, thank you.